See, 1.5 hours says when a glass rod is rubbed with a silk cloth, charges appear on both. A similar phenomenon is observed with many other pairs of bodies. Explain how this observation is consistent with the law of conservation of charge. So basically, what is happening when one object is rubbed against other? Tell me what is happening. So due to frictional electricity, they are not created separately, but the charge is transferred from. No, you don't use the word protons or electrons. One material is losing electrons, the other is gaining electrons. Which one? Which one are you talking about? Sorry, என்ன சொல்லியிருக்காங்க? Proton சொல்ல மாட்டாங்க. It's not a proton. Call it as a positron. So protons சொல்ல மாட்டோம். Protons are something which are there inside the nucleus. So electrons are gained or lost. We'll make it simple. It's not complicated. So electrons are lost by one material, gained by another material. As simple as that. Okay. Next, what about 1.6? So 1.6 is a problem. 4 charges, 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb, and minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. So there is a square across which you have 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb, minus 5 microcoulomb, which are placed across a square of side 10 centimeter. Now what are they asking is, what is the force on charge 1 microcoulomb placed exactly at the center of the square? So 1 microcoulomb is placed at the center of the square. What is going to be the force experienced with? It's 0. You need not solve this problem because if you look at this, this is going to be the force. So let's number them 1, 2, 3, 4, and let me call this as 5. So what is this force going to be? F phi 1. What is going to be the force in this direction? F 5 3. Force experienced by the fifth charge due to the third charge. Similarly, what is going to be the force in this direction and force in this direction? So this is going to be F54 and this is going to be F. So F54 and F52 in terms of magnitude will exactly be the same. Why? Because same combination of charges, same distance. So this and this get cancelled, this and this get cancelled. That's it. So the net force experience is going to be 0. You need not sit and solve this. You can use the logic and tell. So what will you write? How will you write it in the exam? You will say F51 and F53 have the same magnitude and opposite directions. Similarly, F54 and F52 have same magnitude and opposite direction. So each get cancel each other, hence the total force is nullified. Okay. So what is the time? Okay, we'll do one last problem and then we can wind up. So look at 1.7. So 1.7, what are they saying? An electrostatic field line is a continuous curve. That is, it cannot have a break. So if I take an electrostatic field line, it is a continuous curve and it does not have a break. Why it does not have a break is what they're asking. So let's assume it has a break like this. Now, if you place a charge here, the charge starts experiencing force. So when it starts experiencing force, it tends to move. So when it is moving from this point, let's say to this point, what is happening at this place? If at all there was a break. See, first of all, it cannot have a break. If at all there was a break, what is the reason we are saying that it cannot have a break? Because if it has something like this, you are trying to say that the charge is jumping from here to here. But clearly force tells us that the charge has to move either in the direction of electric field or in the direction opposite to electric field, depending on the nature of the charge. So if there is a brake, what will you say? If there is a brake, we are trying to confess that the electron is jumping from one point to another, which is not possible. When I say it is jumping, no, it can jump in multiple ways. You think this is possible? It can have only one direction, right? So it is not possible for the electric field lines to have a brake. Secondly, explain why two field lines never intersect. This we have already discussed. So when two field lines are going to intersect, you can draw two tangents at the same point, meaning the same logic. Q naught is there. Q naught is trying to move in both the directions simultaneously. The same object cannot move in two different directions at the same instant of time. So the expected keyword in your exam is, I have to speak in terms of exam perspective. You will say that at the point of intersection, we can draw two tangents, and two tangents represent two directions of motion of the particle at the same instant, which is not possible. Is that clear? Is that point clear? Right. So these are all some simple problems, right? So I'll do the remaining problems till 24. Generally for board exams, we do not do the additional exercise problems. But if you're preparing for competitive exams, I would suggest you to do that. Right. So till 24, we'll try to do it tomorrow. And on Wednesday, I'll start off the next chapter. Next week, you will have a test. See, 17th alone, I'm not there, I'm traveling. Okay, I'll see what needs to be done on that particular day. As I told you, I might give you some recordings before I go. So work on that day at home and come. Okay. Similarly, I just wanted to tell this also. From 24th, the 23rd, I think, 23rd is Sunday, 24th, that week I'm not in Chennai, but I'll be taking class. So that 1 week for the first 3 days, we'll have online class. Okay. Ah. Somebody left your math textbook here and went. I think it's yours. I found it. Somebody left your textbook in this basket. Please check in the front desk. If it is yours, please take it. Okay. So those are online. Shall we wind up?
Thank you, sir.
Okay. Yeah. I'll see you tomorrow.
Thank you, sir.
Yeah, ma'am.
Thank you, sir.